Well, thanks a lot everybody for being here. It's my pleasure to introduce Renan. That's going to tell us about intermittent morality. Renan is from UdG and he's coming with his daughter Jorge Marco. So you can ask questions to any of them, I suppose. So Renan, the floor is yours, and thanks so much for being here.
Well, thank you very much for the invitation, for the invitation from the department. And today we are presenting a work which combines different topics. Overall, we work on cooperation. So we talk about intermittent morality, social networks, and we like to revisit the ideas of cooperation. So, in order, usually, if you want to introduce cooperation, you need to have some people that they follow a sustainable path. So, here we have, sorry, still learning this, yeah. Okay, so we have a different situation. We want to go from one stable point to another stable point. And if we look at the problems of the environment, it's not just that you can handle this situation with just some taxes or some fines. It needs to be a change overall, so behavioral change. So it's a sort of a change in the mindset, and so that's what we want to see in the mindset, is a sort of change in the social norm. So we want to see how the economy changed from to a sustainable path, and we want to see how it's possible to change the attitudes of the people. So when we think about cooperation, then we talk about the attitudes, and we look at the interplay between extrinsic motivation and intrinsic motivation. So we take a simple example. You have to decide whether you travel by train or by plane. And then you can compare the different aspects. So the airplane is often less expensive, at least if you go if you go a longer distance, shorter traveling time, more CO2 emission and so forth. But you also may experience social pressure, so what's called flight shaming. People may accuse you that you're emitting too much CO2, your footprint is too high. And then on the other side we have the train. It's maybe more expensive, you spend more time, less CO2 emission, which is good, more connections, but you may also experience social pressure. Social pressure because you spend so much time traveling and you're not at home taking care of the kids, spending so much traveling, so you don't work so much. So there are also ways of social pressure. So we look at the network side, and we look at the social pressure. So we have the network. It's a very simple network here. There is the agent I, which is in the center. It needs connections. The connections are either green or red. So green, the green ones are people who are compliers. Let's say they take the train, for simplicity. Or they are defectors, they're traveling by the airplane. So then they exercise social pressure. And here in our model, everyone exercises social pressure. So the green ones, the train, people who use the train exercise pressure on agent E. So he will receive pressure from the compliers at agent E. If the agent E decides to become a defector, then he will receive pressure from the compliers. And vice versa, if he decides to become a defector, if he decides to become a complier, he will receive pressure from the defectors. So the social decision problem is you have to weigh the costs and benefits of going by train or going by plane. So there's one, maybe it's possible to look at the social side and at the private side. So from the train, maybe from the social side, it's optimal that the people take the train. And from the private side, it's optimal to take the plane. So in this case, so if you take the train, maybe you have extra cost. Extra cost of time or money. So all these are incorporated in the extra cost. And also the social pressure you receive may form part of the extra cost. But if you take the train, you may also experience extra benefits because your personal values align with your actions. Because you can identify yourself with what you do. So you proclaim, I'm an environmentalist and I act as an environmentalist. Okay, so in our case, from now on we'll only talk about extra cost, not extra benefits. And basically, the extra costs are similar. We use the term extrinsic motivation or extra cost. It's the same in our case. And it's the difference between the utility you receive from pro-social versus non-social, non-pro-social behavior. So if you take the train, you have extra cost, you pay more money, and this is what we determine extrinsic motivation or extra cost. So the intrinsic motivation, so we talked about the extrinsic motivation. Now the intrinsic motivation is a little bit more complicated, but basically it's your behavior is formed by values and beliefs. Values and beliefs form your attitudes, the way you act within certain situations, and this is basically what we say is the intrinsic motivation. How you treat others and approach situations. And this, your attitudes give rise to a behavior. The behavior is to take the train or to take the plane. So then we see that given the same extra cost, people do not do the same. I mean, if the train is, let's say, 50 euros more expensive, some people decide to take the train even though it's more expensive. And other people know. So there's something else which is influenced here. This is the intrinsic motivation. The intrinsic motivation may override the extrinsic motivation, the extra cost. So we are willing to accept the extra cost because of your intrinsic motivation. So, but other people may say 50 euros is too much for me. Given the price difference, my intrinsic motivation is not so high. If I have to pay 50 euros more, then I forget about the train, I take the plane. Okay, so now we combine these factors, which is basically intrinsic motivation and the extrinsic and intrinsic motivation. But we see that there's a sort of interplay between extrinsic motivation and intrinsic motivation. But it's also, the extrinsic motivation is not only the difference, or let's say, the intrinsic motivation, the extra cost, also depend on the public infrastructure. So I take the car or I take the bicycle, also depends how many bicycle lanes there are. If there are no bicycle lanes, then it may be very expensive for me to, or less favorable to take the bicycle. So if we look at what standard economic theory says, if you're a rational agent, then what you do is to maximize your private utility. And at the end, what you consider tangible and intrinsic return for a private utility. And then you will not necessarily behave pro-social, you behave opportunistic or particular, well, your private benefits. So there are extensions. The extension are maybe there's altruism. Altruism is a person has a utility, but takes into account the other utilities, or let's say the utilities of other people. Okay, so you have altruism, you have a warm glow, then the utility you receive is only not from the benefit you get, but also you get utility because you give something to other people. And then there's also intrinsic motivation, which explains cooperative behavior. However, what this theory so far, these three, do not explain that some people in certain circumstances decide to act cooperatively, in other situations not. So this is what we call intermittent morality. So the intrinsic motivation may be a fixed term, but it does not express always the same amount. It may be expressed more severely or less. So this is what we have here, the interplay by extrinsic and intrinsic and intrinsic motivation. If the intrinsic motivation is very low, intrinsic motivation is high, extrinsic motivation is high, so the extra costs are very high, then it's not quite clear what will come out. Here, it's if the extremes are here, so if the intrinsic motivation is low, you don't feel a lot like doing it, but and on top you have high cost, then of course your cooperation will be less. So what we see is high extra cost may crowd out intrinsic motivation. So if it's very much more expensive, even if I have an intrinsic motivation of 5, but if the costs are very high, then I forget about my intrinsic motivation. And vice versa, high intrinsic motivation might override the extrinsic cost, the extra cost. Okay, so if we look at the literature, so they looked at intrinsic, extrinsic motivation, but mainly they looked at them separately. Of course, there are some studies which looked at it, the famous case of blood donation, where they observed that if people are not paid for blood, for donating blood, they are willing to donate, but if they are paid, then they decide not to donate blood anymore. So this is one case. Another example in the literature is Ida and Weibel. They looked at the Homo moralis, but this is only if you look at intrinsic motivation. You don't look at extrinsic motivation, only intrinsic motivation. In the intrinsic motivation, it's a fixed parameter. Then you also have the paper Werner Bohm-Tirol, that is based on self-perception theory. Basically, you have some introspective, you want to find out what type of person you are, whether you're intelligent, whether you're sympathetic or not. And you do this by some sort of game they propose. And you play this several times, and then you find out whether you're intelligent or not, okay? So, but the problem with this approach, the Panabo and Tirol, is that it's not very applicable. Because in their model, they need a lot of exogenous parameters. They need, for instance, to decide what type you are. Let's say pro-social or not pro-social. And they also need to define a probability whether you remember whether you're pro-social or not. The remember is because you're not sure what you are. You have to find out whether you're intelligent or not. But it may be that you cannot remember so well. Remember is not, they call it remember, but basically it's a sort of experience. You want to find out. That's why you have to repeat the game, repeat to find out. And most importantly, they have, if you're a type A, they define the probability that you act pro-social. If you're type B, you act pro-social with certain probability. So the probability that you act pro-social here is not endogenous, it's exogenous. That's why we didn't follow this approach. Another thing is that we have a social network where you have, let's say you have 10 links, you interact with these people continuously, many times. You're always acting with the same person, the same counterpart, and so it's a repeated interaction. So it's not very likely that you play the game many times all over again. After 2 or 3 times you have found out whether the person is intelligent or not. So you don't have to repeat it all the time. So this is more a different kind of game. Here we apply it to a social network. So in our game they have a repeated interaction, and every agent receives and exercises social pressure. The agent receives utility from intrinsic motivation. Intrinsic motivation basically saying that you act in accordance with your beliefs, and extrinsic motivation, which are basically extra costs. Okay, so so in our game, the agent's behavior is an adaptive game. Basically means you observe what happens next to you, and based on this you decide, you adapt. You can think about a game of social network. There are 1,000 agents. Some agents are connected with other agents. So maybe your neighborhood consists of 10 other agents or 20 other agents. And you decide to support the pro-social cause or not. You can think of an aquifer. Either you extract too much, what is optimal for you, or you only extract a small part or lesser part, which is optimal from the social point of view. So it's a repeated game, because in the case of an aquifer, every year or every month you have to decide how much water to extract. Then we assume that you have bounded rationality. So why do we assume bounded rationality? If you have a network with 1,000 agents, you observe what your neighbor do, but you do not observe what the neighbors of the neighbors do. So one can think, okay, we play a strategic game, but this is impossible. I mean, that's why the bounded rationality comes in, because if I have to calculate what my neighbor does, I also have to calculate what the neighbor of my neighbor does, and the neighbors of the neighbors and the neighbors and so forth. So it's not possible to calculate. I mean, we assume that people are don't have enough rationality to calculate the behavior of 1,000 other agents. According to this, so then you would act strategically if you were able to calculate the behavior of all the people at the same time. But I think it's more reasonable to assume that people look at the neighbors, what they do, and based on this they decide what they do. So the neighborhood is the reference. But you observe your neighbors, but you know what comes out, or the outcome of the game you don't know. It's highly uncertain, because the neighbors depend on the neighbors, and the neighbors on the neighbors, and so forth. So every agent is affected by all other agents. So that's why it is uncertain, because of the complexity, and the complexity also leads to bounded rationality. Okay, so we look at a community of n agents. They have action profile A, and they have benefits pi. Okay, so, and there's a capital A is a public bad, let's say the extraction of water, in this case, and what we postulate is the benefits. The private, you can act in 2 ways, either opportunistic or pro-social. And the benefits from private or opportunistic are higher than the benefits from pro-social. So it pays for you not to collaborate. Okay, so now we make a simplification. We say cooperators the action is 1, and for non-cooperators it's 0. So they have either 1 or 0, and then we have a public bed, and this is the public bed here. So if all are non-cooperators, the sum of here is 0, and the public bed is equal to n, because there are n agents. So the public bed ranges from 0 to n. Then we have intrinsic motivation. We scaled it from 0 to 1. Then we have the degree of your neighbor, of your agent, of the agent. It means how many connections the neighbor has. So if I have 10 neighbors, my degree is 10. Then within the neighbor of the 10 neighbors, I may have 5 compliers, which act pro-social like me. So there's the number of cooperators C capital. And then we also calculate the share of cooperators. The share of cooperators is basically C capital C divided by D. So if it is a small community, you get the same pressure if half of the people are compliers. If you decide to become a defector, half of the people will pressure you. It doesn't matter whether the half are 2 people or 20 people. It's the share which determines the pressure. And the peer pressure is by cooperators, the omega C, on the non-cooperators. So the cooperators pressure the non-cooperators. Likewise, the non-cooperators pressure the cooperators. But pressure costs are not free, so they are actually pressure costs. These are the pressure costs here for the cooperator and for the non-cooperator. So now we look at the agent's utility. Make clear that here the U is a small u. It's not a capital U. Later on I will introduce a capital U. That's why I'm saying this. So if I'm a cooperator, so my C is 1, then in this case, the C is 1. No, this is different now. Okay, this goes away, this goes away. I'm left here with these costs. I'm pressuring, and this. Okay, I'm receiving this. Okay, here I'm a cooperator, so I receive pressure from non-cooperators. And I'm also pressuring, and this creates cost for me. Now, we look at the interface of extrinsic and intrinsic motivation. We look at the agent's utility, capital U. So here we take the U we had calculated before for the case of a cooperator and a non-cooperator, but they are weighted. They're weighted by the intrinsic motivation. Okay? But the weight is not a fixed term, it depends on delta.
Can I just, one clarification question. So you are only affected by those individuals that are connected to you, not by other individuals that belong to the community but are not connected to you?
No.
There's no this indirect connection?
Indirect, yes, because other people, let's say my neighbor's neighbors are affected, and then my neighbor changes because of their neighbor.
Okay,
but not indirectly. I only observe what my neighbors do, and I only receive pressure from my neighbors, not from the neighbors' neighbors. Indirectly, yes, because it's a cascade in a sense. So the weight is here is the delta, and now I look at the delta, if it comes up. It comes up later. Okay, now it comes up. So we have here the cooperator. This is the weighted agent's utility of a cooperator. So that the A has disappeared now because A is 1, he's a cooperator, the action is 1. So he experienced the benefits of a cooperator, receives pressure from the non-cooperators, and pays the cost of exercising pressure. And likewise, if A is 0, so he is a non-cooperator, he gets the benefits of a non-cooperator, receive pressure from the non-cooperator, and exercise pressure on the cooperators. So I'm a non-cooperator here, so I have cost. Okay. So the question is, what is this delta here? Okay. And delta measures basically the difference between utility difference between the non-cooperator and cooperator. Basically, the higher is the difference between the utility of the non-cooperator versus the utility of the cooperator, the higher will be the influence on the kappa. So this is basically saying the extrinsic motivation influences the intrinsic motivation. Extrinsic motivation influences intrinsic motivation. The kappa is not a fixed term. It depends on the utility difference. If the utility difference is very high, so if the train is very expensive, maybe my intrinsic motivation is not so important anymore. So that's what the idea behind this is the delta moderates the influence of the intrinsic motivation. If the extra costs are very high, intrinsic motivation is overridden. And we also have, okay, the delta is formed by two terms, by gamma and this delta here. And gamma is socioeconomic context. So basically, if I'm a rich person and the train costs 50 euros more, then I will say forget about it. But I only have a 500 euros income, then $50 more or 50 euros more are more important. So this gamma here reflects the socioeconomic context. Very simply said, it could be the income of the people. It could also be the decision frequency. If I take the decision every time, maybe I'm more careful about it. But if I say, oh, it's just one day, then I may be willing to spend more money taking the train. But if I take the train every day, then I will say, well, I have to be careful, no, to spend so much money. So if we look at the weight, so what I'm saying here is this factor here, kappa to the delta, if we look at it for the case of kappa 0.6 and gamma 1, then we see that the weight of the cooperator's utility decreases. If the utility difference between complier and cooperator and non-cooperator is 0, they have the same. The train is equally expensive as the plane. Then the weight is 1 for the complier and 0 for the non-complier or non-cooperator. So it basically means that if there's no difference, then I will act pro-socially. But as the extra costs increase, so these are extra costs, basically mean here. 0 means there's no difference between the utility of a complier and defector. 1 means it's the double. It's twice, extra costs are twice as much as the utility of a complier. See? So this is 100% to 100% more expensive than the utility of the complier. With the utility of the complier is set in our scale, we have used the scale here is 1. So 1 means 1 more time expensive than the complier. The complier is set to 1. So this is, okay. This was the case for gamma, gamma equal to 1. And the next situation is for a gamma equal to 5. So in this case, the intersection of the weights is very close. Before it was not, it was far out. But here, if the extra costs are about 50% of the, if the compliance causes 50% more cost, then the weight I attach to the complier is higher. Sorry, to the defector is higher than for the complier. The blue line is the non-cooperator, okay? So the weights change as the extra costs increase. So what we also see is, okay, now we have the weights, but the question is how people decide. How do they decide? And what we propose here is the higher is the difference, the extra cost, the higher the benefits I get from non-cooperation, the more likely it is that I'm not cooperating. So if the opportunistic behavior gives me a lot of benefits, it's more likely that I behave opportunistically. And this is basically expressed here by the softmax rule. This is usually called probabilistic reasoning. So it's not rational. It's not saying if A is greater than B, then you choose A. There's a probabilistic reasoning. So the probability that you choose A is higher, the greater is the difference between them. And this is, for instance, in stochastic games that is used in Bayesian learning or quantum response functions models. So the higher is the difference in the utility, the more you for the defector, the more likely it is that the people will defect. The incentives to defect are higher.
Would it be consistent with signaling theory, where you're not signaling to yourself, but you're signaling to others? So they know that there's this difference in utility from the prosocial to the selfish action, and therefore I can infer how likely are you to be a good person. And
so you mean, well, I observe what the other people do, but I don't know the utility of the other people. Because my neighbors depend on their neighbors, and I don't know what the neighbors of my neighbors, the action have chosen.
Exactly.
So I cannot calculate the utility of my neighbors' neighbors. But the signaling game, you mean that what do you want to signal, whether you're pro-social or not?
Yeah, you're interested on your reputation in your community.
Yes.
And therefore you want to maximize how likely it is that others think you're a nice person.
Yes. Okay, I can imagine it's possible, but then you need a stock variable, which is your reputation. No? We don't have this. So we only have one stock, which is the public bet here, the extraction of the common property. Okay, now I wanted to say this. So if the utilities, the capital utilities are equal, then you see PC, the probability to become a complier is equal to 1/2. So then you are indifferent. So utility difference is 0. I am indifferent between one thing or the other. This is the decision rule. And if we look at the decision rules, here we have the case of the utility of the complier is always set to 1, gamma is 1, and capital is 0.5. So you see the extra benefits of 100% makes that the probability now, from here on, the probability that you will act as a non-cooperator is higher than for the probability of acting as a cooperator. Initially, if the extra benefits, the extra costs are low, here the extra costs are low, then the probability is higher for you to become a cooperator. But as the extra costs increase, you say, well, now it's getting too expensive for me, and I will act opportunistically. The same on this slide here. The only difference, the gamma now is higher. So the socioeconomic factors are important. So let's say this person is a more poor person, is poorer. So it means that the break-even point, or the switching point, is smaller than before. So in the first case, it was around 1.8, 1.2, where he changed, and here it's, I don't know, 0.7. So if he is poorer, then the extra benefits, the increase in extra benefits, make him change earlier. So now we come to the game. We have the initialization and we have the game. So the first thing is we have to set up a network. So Jorge is a specialist in networks. He set up a network in the computer, following certain rules. I will explain a little bit later on. Then we have to assign some parameters, which is basically the number of compliers and the distribution of the compliers. Well, let's say we have 1,000 agents, 30% of the agents are compliers. We can distribute them in many ways. Maybe they're all in one corner, or they're evenly distributed over the network, or there's a lump sum here, a lump sum here. So there are many, many ways how to distribute 30% compliers of the 1,000 agents. And we also have to distribute the intrinsic motivation. There are also many ways to distribute them. So later on I will talk about the distribution. And then starts the game. The game basically is you observe what your neighbor does, you receive your pressure, you act, you exercise pressure, and according to the softmax rule, you decide to become a complier or defector. So this is one round. The next round is you decide again. Things have changed because your decision of the neighbors have changed. And the public good maybe have changed as well. But basically agents observe their neighbors and they act simultaneously. So there's initialization. Here is an example of a simple initialization. The network here, there are only two agents. Only two agents. And they can choose 0 or 1. 0 or 1, complier or not complier. And then we say, we look at the distribution of 0.5 and 1. Okay? We could also look at 0, but we don't look. 0 would be, both would be 0. 0.5 is 1 is 1, and 1 is 0. And 1 is both are 1. And then we take, for the 0.5 case, 10 examples, 10 drawings, and associate we associate a value to one of these two agents. Okay, we repeated this 10 times. This is from a uniform distribution, and then we do for every one of those, we look at the distribution of the intrinsic motivation. In the intrinsic motivation, we look only, again, to simplify things, at two values, 0.25. The expected value is 0.25 and 0.75. So these are expected values. So we set our computer The expected value is 0.25. Then he makes the drawings. So for this first case, we repeat 10 drawings again from this distribution. Overall, we get 400 networks because we have our 1,000 agents and we have to initialize the network. We have to assign the number of compliers, not only the numbers, we have to assign every agent whether he is a complier or not. And we have to assign an intrinsic motivation to every agent. So altogether we have 400 networks. This is easy to calculate because the dimension of every distribution is 2, so it's 2 times 2, and every repetition is 10, so it's 10 times 10 multiplied by 2 by 2, it's 400. Okay? I'm saying this because later on you will see a big number and you probably do not know where does this big number come from. Okay, now we have our case. The case I just explained was an example because there were only 2 agents. Now we have the number of compliers. We look at 11 different values. The expected value of complier is 0. The expected value of compliers is 0.1, 0.2, and so forth. So altogether, we have 11 values. And we do the same for the intrinsic motivation. 0, 0.1, 0.2, and so forth. So the dimension of each set of the compliers and expected values of compliers and intrinsic motivation is 11, and we repeat it for every distribution 50 times. Then we get 11 times 11 times 50 times 50. So altogether, at the end, we have 300,000 networks. So our simulation, our game, for every network, for every of the 302,500 networks, we simulate the game. So the equilibrium here, theoretically it's not much we can say about, but basically equilibrium is reached if the number of compliers stays the same over time. And the stock also is the same over time. And then we look initially at the case of the game, but only for one period. So what we call a static game. And this should be the probability of complier 0.5. So this line here indicates the probability of 0.5. So all combinations of intrinsic motivation and extrinsic motivation that generates the equal probability along this line. I forgot something with the networks. Okay, so we have the networks, but once you have calculated networks, you have assigned the C and tau, the intrinsic, the number of compliers, then you can calculate the extrinsic motivation, because only if you have the values, you can calculate the pressure. So this is obtained thereafter. Okay, so this is with no interaction, so extrinsic and intrinsic motivation are not interrelated. And if they're interrelated, you get this line here, which basically means that to the right you have cooperation, because the separation line is here, which means the probability to become a complier or defector is 0.5, and here, once you cross this line, the probability to become a complier is higher than 0.5. So the area of attraction for cooperation is much higher with interaction than with no interaction. And here we have the extrinsic motivation. Okay, the extrinsic motivation. This is what we determined here before. It's 1 minus UC divided by UNC. So this is it's not the capital U, it's the small c, the small u. So if they're identical, then you get 1, so delta is 0, then you're here, okay? But if NC is very large, these terms disappear, so you're 1, so you're up here. So if the extra cost are very, very large, you are here. So this is a different scalar we use the graphics before. But basically it's the same. It's another way of presentation. And then if we calculate the outcome of the game, the expected outcome of the game, because for every game we have calculated 300,000 games and calculate the expected value. Then you see without interaction that all this area, this combination of extrinsic and intrinsic motivation does not lead to cooperation. Only if the intrinsic motivation is higher than 0.8, cooperation starts up. So what drives the results here are the intrinsic motivation. Even if the extrinsic motivation is the extra costs are very low, the train is just €2 more, it's not sufficient without interaction. You need to have high intrinsic motivation. Only a high intrinsic motivation gives you more cooperation. But if you take into account intrinsic motivation, the interaction between intrinsic and extrinsic motivation, you see that even if the intrinsic motivation is low and the extrinsic motivation is low, you may find some cooperation. So in other words, even if the intrinsic motivation is low, you find cooperation if the extrinsic cost or the extra costs are small. So I'm willing to pay. I'm willing to take the train if the extra costs are low, even though my intrinsic motivation is very low. Then we looked at the case of polarization. So I mentioned before, we have to distribute the intrinsic motivation. And here we say the intrinsic motivation, the expected value has to be 0.5. But 0.5 we can distribute in many ways in the network. All extremes, so they're here, so the extreme points still gives me an expected value of 0.5. Or they are very centered, so these are the extremes. So here we have a high polarization with a red and yellow line. And if we look at this line here, we say if there's a high polarization, we find a stable level of cooperation. According to the extrinsic motivation, if the extrinsic motivation increases, if there's polarization, it does not affect the cooperation. Saying that the train gets more and more expensive, but if people polarize, they say, whatever it costs, I take the train. Or whatever it matters, how cheap is the train, I take the plane. This would be sort of the effect of a polarization of intrinsic motivation. But if the polarization is not so high, then you see what you would expect. Initially the cooperation is high, but as the extra cost increase, people say, well, okay, now it's getting too expensive, I don't take the train anymore, I take the plane.
So in the stable case, you have like some super compliers and some people that don't care about the environment.
Well, basically they're isolated, you know, because if I have here, these are my 1,000 agents here, and if they're all compliers here, they're all defectors here, non-compliers here, they cannot invade the area of the non-cooperators. They cannot pressure enough because they are all together. It's like humanization. They cannot. I'm saying invade, but basically mean the pressure is not sufficient to change the behavior, no? Because they,
Yeah.
either because they are sort of isolated and there's only one link, no? Depends on the type of network. If there's only one bridge to the area, then it will never be invaded.
Yeah. No, I think that the result is very logical because since you cannot observe your neighbor's neighbors,
Yes.
so that means that you create an isolated community,
Yes.
and so they abide by those rules. Yeah.
Mhm.
So that's
Yes.
so the cooperators are cooperators, the non-cooperators are non-cooperators.
Yes.
Yeah.
So if they're not well mixed,
Yeah.
the compliers and non-compliers within the networks, there are different sections, compartments, and it's difficult. And finally, we look at different types of networks. Here we have the red line is a complete network, which means every agent is connected with all other agents. Let's say there are 10 agents in the network, and everyone has a degree of 9 because it's connected to everyone else. Then we have a random network, so the probability that your link with the neighbor is 0.5 or whatever. There's no special. And then there are scale-free networks, which follow a certain rule, where it's not just the probability, but often it's the kind of type you are, you're more associated with the other agents, and you will find what they call hubs, by agents which are connected to many other agents. They are sort of center agents. In random networks, you don't find this. In scale-free, you find an agent who's connected to many other agents. So it's a different, there are a certain number of agents which have a special neighborhood because they have a very high degree. Okay, so then you will see this is the complete network, so it's very immune to any changes in the intrinsic motivation. So if you look at the policy, if you think, for instance, you're initially at point A, you want to go to the other side of the line, which is the tipping line, which is the probability of 0.5. So here you can, if you're A, and you know it's a complete network, you can choose either formal enforcement, basically a tax or fine, or informal enforcement, you want to change the network or stimulate. Then informal enforcement basically means to change the attitude of the people also. Then you know it doesn't make any sense because if you move horizontally, it will not change anything. So if there's a complete network, the only policy which is recommendable is fines. Because informal or nudging or whatever is not effective. If you're at B, you have two options. You can choose the informal enforcement, which is basically reducing the extra cost. I give a subsidy for the train tickets. So train is more effective. Then the extra cost decrease and people become compliant. But you can also choose intrinsic motivation here. This could be, for instance, to foster the cooperation between the compliers, or to foster, to have more links between the agents. 2 minutes, yes. If you're at C, okay, it's again, you can hear whatever is the network, you can choose between the two options. You can choose between informal enforcement going to the right or reducing the extra cost, which is going downward. If you're at D, you have a scale free, you have two options. But if you're at D and you face a random network, then it doesn't make much sense. Informal enforcement is very expensive. You have to increase the intrinsic motivation a lot. Whereas this one is far easier because you only have to reduce the cost a little bit. And E is similar. So in E, if you have E, informal enforcement is probably not very promising because you have to increase the number of increase the degree of intrinsic motivation.
That's one question. I don't know if it's really related. Would it make sense in this context to use centrality measures in discount networks?
Centrality measures of the targeting, no?
Yeah.
So you can think about targeting, but this is what we want to study later on. But if you have a scale-free network, so then you have hubs. If you have hubs, you may say, okay, it's interesting to target this person because he is connected to many people. But if you target a hub, he is connected to many people, but the neighbor of the hubs are not connected, usually. Because he knows many people. Everyone knows the king, but the people who knows the king not necessarily are connected. So the hub will not receive a lot of pressure because the neighbors are not connected. So he may be resistant. So it could be that he does not change. Especially the hub, if you target a hub and he has to pressure all the degrees, he has very high cost because he has to pressure many people. So a hub may be a good thing or not, depend on the situation whether the hub is a defector or a complier. So if he is a complier, he helps to pressure the neighbors. Okay, so initially I said fines, exercising fines or informal enforcement is a way to improve cooperation, but it's necessary to introduce a sort of change the mindset in the long run. So if we change in the long run a mindset change, then this would mean that these curves have a positional shift to the left. The example is 20 years ago everyone smoked in a bar. This was highly questioned. Nowadays everyone thinks this is the right thing to do. No? So the social norm has changed from smoking in the bar to non-smoking in the bar. There are no fines anymore. It's not necessary to impose fines anymore. Initially, yes. But once the people have changed and have internalized the idea, then you can drop the fines. Then this would be a change in the mindset, which means a shift, a positional shift of these tipping lines. So basically the main takeaway. So we looked at the motivational factor, which is extrinsic and intrinsic motivation, but they are intersected, they have interplay, extrinsic motivation and extrinsic motivation interact, and also we have socioeconomic factors. So basically intrinsic motivation is not sufficient to explain the behavior of the people. So finally, we also looked at the policy. Depending on the type of network, you define one policy or the other. So the study helps you to define the policy in accordance with the type of network. And finally, the high levels of parallelization may prevent, if it's very polarized, may prevent first best solution. But on the other side, they may support mixed equilibrium. Because if the first best solution would be all compliers, but if you have a high polarization, then you may settle for mixed equilibrium, where they have both at the same time. Okay, thank you very much.
So fortunately we don't have a lot of